Hello everyone, today I'm with you to explain solution of one-dimensional wave equation by method of separation of variables. In the previous videos, I have explained derivation of one-dimensional wave equation as well as derivation of one-dimensional heat equation. If you have not subscribed my channel yet, subscribe this channel to get more videos which I'm going to upload further. Similarly, if you like this video, give like button in my YouTube channel. Now we have wave equation dou square u by dou t square is equal to c square into dou square u by dou x square. This also can be denoted UTT. Here UTT means dou square u by dou t square is equal to c square into u x x. Now, by the method of separation of variable, we are solving this wave equation. So initially, we take solution u is equal to x into t, where x equal to x of x. That means x is function of x only. Means it is containing only x terms or x variable. T is equal to t of t. That means it is function of t only. Be the solution of partial differential equation given. Hence, substituting this u equal to xt in the given PDE, we get dou square xt by dou t square, because u is replaced by xt, is equal to c square into dou square xt by dou x square. Look at here x is function of x only. That means there is no any t term in x capital X. Therefore, we take this x outside to this derivative. That means we can write x into dou square t by dou t square. Also, since this partial derivative term having only one independent variable t, it is equivalent to write ordinary derivative. So dou square t by dou t square, in the next step we will replace it by d square t by dt square, because we have only one independent variable. Similarly, right side c square into dou square xt by dou x square. Here independent variable is x. So t term let me take out, being t is function of t only. And dou square x by dou x square will be changed to d square x by dx square, as we have only single independent variable. So we write x into d square t by dt square is equal to c square t into d square x by dx square. Now dividing this throughout by c square xt, what happens? See here, in the left side, we have x here. If you divide by c square xt, x will cancel and 1 by c square t will remains here. Similarly, if you divide here c square 1 by c square xt, if you divide by c square xt, c square t cancel, 1 by x remains. That is what written here. That is 1 by c square t, d square t by dt square is equal to 1 by x into d square x by dx square. Now equating both sides to common constant k, means both equation we have, this we equate to a common constant k. Let us see what happens. First one is equal to k, that is 1 by x d square x by dx square equal to k, and second one is equal to k. Now let us simplify or modify. Look at first one. Here 1 by x, if you shift right side, this will be merged with k. So we get d square x by dx square as kx. Now taking kx left side, we get d square x by dx square minus k into x equal to 0. Similarly, right side, 1 by c square t, if I shift to right side, will be merged with k into c square t. Taking c square kt left side, we get d square t by dt square minus c square kt equal to 0. Or this can be written as d square minus k of x is equal to 0. First one, this one, can be written d square minus k of x equal to 0, where this capital D square stands for d square by dx square. That is this one. Similarly, second one, that is d square t by dt square minus c square kt equal to 0, can be replaced by capital D square minus c square k of t, where here this d square means d square by dt square because t is independent variable. Now, here k is constant, that is what we assumed. So, now let us discuss various possible cases for the k. So, first we will check for k equal to 0, and next we will check for k is positive quantity, and next we will check for k is negative quantity. So, we will check different cases, 3 different cases, one by one. So, first k equal to 0. So the equations, that means what we derived just now, d square minus k of x equal to 0 and d square minus e square k of t equal to 0 becomes, putting k is 0, what happens? This k is 0 means d square x is 0. Here k is 0 means d square t equal to 0. So we get this equation. Now this is second order differential equation, homogeneous differential equation. Solving this by writing auxiliary equation. So auxiliary equation for both differential equation, this as well as this, auxiliary equation is d square equal to 0. Or we can write auxiliary equation in terms of m also. That means we can write m square equal to 0 also, or simply you can write d square equal to 0 also, as per your convenience. So therefore d equal to 0, 0, being this is second degree polynomial, so it should have 2 roots. Even it is repeated, no problem. So d equal to 0, 0 are the roots of auxiliary equation. So corresponding to first differential equation, auxiliary equation d square equal to 0. So d equal to 0, 0. Solution is c1 plus c2x into e power 0x. We know that whenever roots are repeated in a homogeneous differential equation, we know how to write the solution. That is complementary function, itself solution, c1 plus c2x into e power 0x. Similarly, for second differential equation d square t equal to 0, auxiliary equation's root d is 0, 0. Therefore, its solution is t equal to, here variable is t, c3 plus c4t into e power 0t. Here we introduce c3 and c4 as constant because already once we introduced c1 and c2. Now we know that e power 0x as well as e power 0t is 1. So x is equal to c1 plus c2x and t is equal to c3 plus c4t. Now, initially we have taken solution for this this partial differential equation, that is wave equation solution, we assumed as u is equal to xt. Now we got expression for x and t, therefore we just multiply the expression what we got for x and t. That is c1 plus c2x into c3 plus c4t is solution for wave equation whenever constant k is 0. Now let me discuss another. When k is positive, so k is positive, I just denote it as k is equal to plus p square, because whatever value you give for p, if you give negative value, then also negative p square, negative value whole square will be positive, so k will be positive. If you give positive value, obviously k is positive. That's why, so k is equal to plus p square is always positive. So let me take this as value for k. So equation, this is the equation what we derived, d square minus k of x equal to 0 and d square minus e square k of t equal to 0. Here we are supposed to substitute the value for k equal to p square. So after substitution we get this result or this expression. Now Auxiliary equations are, first differential equations auxiliary equation is d square minus p square equal to 0, and second differential equations auxiliary equation is d square minus c square p square equal to 0. That means d square equal to p square or d is equal to plus or minus p. This is solution for auxiliary equation of first differential equation. Now d square equal to c square p square or d is equal to plus or minus cp. This is solution for auxiliary equation of second differential equation. Now let us write solution for both. X is equal to, here let me introduce c1 dash as the constant because c1 we already discussed and we just introduced. So here we introduce c1 dash, c2 dash, c3 dash, c4 dash as the constant terms. So c1 dash into e power px, because roots of auxiliary equation are plus p and minus p. Whenever plus p minus p are roots, we know how to write the root. We know how to write the solution. So x equal to constant into, that is c1 dash into e power px plus constant into, that is c2 dash into e power minus px. And for the second solution, that is d equal to plus or minus cp, that is roots are plus cp and minus cp. So t equal to c3 dash constant into e power cp t, here variable is t, plus constant into, that is c4 dash into e power minus cp t. Now we have assumed solution for this given wave equation is u equal to xt. So we just substitute the expressions what we got here, that is x into t, that is equal to c1 dash e power px plus c2 dash e power minus px into c3 dash e power cpt plus c4 dash e power minus cpt. This is the case whenever k is positive. Another case, that is when k is negative. So how we can denote this k is negative? That is k is equal to minus p square, because whatever value we give for p, either negative or positive, p square always positive, but minus of p square will be always negative. So we have this differential equations. Here we are supposed to substitute the value for k. So k equal to minus p square. Let me substitute here in the first and second. So we get d square plus p square of x equal to 0, as well as d square plus c square p square equal of t equal to 0. Writing auxiliary equations, d square plus p square is 0 and d square plus c square p square equal to 0. That is d square equal to minus p square, that means d equal to plus or minus ip, where I is imaginary, and from second one we get d square equal to minus c square p square, that means d is equal to plus or minus icp. So we got the roots, and whenever we have complex roots, we know how to write the solution. That is x equal to c1 double dash, here because c1 dash we already introduced, so just it is constant, constant into cos px, that is c1 double dash into cos px plus constant into sin px, that is c2 double dash into sin px. Similarly for t equal to, we just write because d equal to plus or minus icp are the roots, complex roots. So solution is t equal to c3 double dash cos cpt plus c4 double dash sin cpt. Now we know that u equal to xt, so substitute expressions what we got for x and t. That is u equal to c1 double dash cos px plus c2 double dash sin px into c3 double dash cos cpt plus c4 double dash sin cpt. So we have discussed all possible cases of heat wave equation. Its a solution we have discussed by the method of separation of variables. Thank you for watching.